Okay, so finally, let's actually get into what this class is about, which in a nutshell could be modeling or visualizations for form, fit, and function. And of course, we're doing what's are called concept visualizations. They're the very initial part of the design. They carry all the way through, but they're there so that we can visualize the concept and start addressing questions about form, fit, and function. So let's see what those mean. Here we've got form, and it's the basic characteristics of external dimension: weight, size, and often visual appearance of a part or an assembly or a building or a civil landscape or a landscape. So form, fit, and function go in a lot. But the form is basically the shape. Sometimes it includes the weight, the size, the visual appearance, whatever happens to be important. So here is one where you can definitely see the form. This is the form of the design. Fit refers to how things connect together. So in this case, and I can tell you some really interesting stories about that. In this case, it's does the do the functional items, places to sit, places to store things, doors, actually fit. Now, I worked on the Academy of Sciences building, the design in the central utility plant. I was the wet side modeler for the central utility plant. I was a subcontractor of a subcontractor of the mechanical contractor. And just fit can really get in the way on some of these things. So there was a lot of work to make sure that all of the piping and the equipment would hook up to each other. They all had their very specific sizes, dimensions, weights. And so at one point, it was a design build. So they were building it as it was being designed. And we got a frantic call that we had to redo some piping because the boilers would not fit through the doors. And we went back and we looked. Yes, they do. There's 2 inches of clearance. There's no problem. You can get it in. We've laid it out. And they go, yeah, you forgot that it has to be on 3-inch diameter rollers to get in. It hits by 1 inch. Oh. So even when you know the form, sometimes the fit in architecture can be problematic. And of course, since the product that I was working on, which was the wet side piping, was the smallest, easiest to change, it was all my stuff that had to change. And of course, we were happy to do it. First of all, we got paid more money for it. And second of all, it solved a serious problem. And when you're doing design build, there's no way to understand the full complexity of something like that. You just understand that those things are going to happen, and you do, coordination meetings to catch them as soon as you can. And we were able to do that. So, fit. How does things go together? Join or fit together. And function, of course, are the criteria that have to be met. So, on this picture here, this is an architectural, it's from a commercial remodel project that you might even do in this class, where there's an existing building and you have to do certain things and maintain certain parts of the form. You can change other parts of the form and look at it to see if things fit to meet the function. So there it is in an architectural or an interior design industry. And here it is. Of course, this is my industry. I'm a mechanical engineer. And here the form has many parts of it. Each of these gears has a form, and those forms have to be correct if they're going to fit to make their function. And you can see there's some outside. So there's some form here. Now, this form was made by creating what's called a positive space. This was all one form, and then we cut away the negative space so that this particular set of gears fit exactly. And then the form and the function meet together in this one because this inside diameter is the bearing surface the for the bearing. Okay, so the fit is very critical between those, but the form is the basic. Now look, in our class, we're going to mostly be looking at what's called the concept model, the primitive model. We don't need to know the form of this little cutout here or what it's for. We don't even really need to know the exact form of these. Those might change later on, but we need to know what they do, so they have to be identified. Most of you probably couldn't tell me what the function of these little things are for, and maybe as we're doing our concept design, they're not needed until later on. These were added in at a later place. So for our class, the form is going to be made basically by primitives. If you can use a rectangle or a box, a cylinder, or what they call a pyramid or triangle or wedge, that's the level of conceptual design that we want to use so that you can then annotate, as you see here, to further develop the design. So most of our modeling will be done with. But there you go. That's form, fit, and function as it relates to this class, which is for concept modeling, so that the design can be developed by continually adding more and more complexity to the model as we